Segment 1 Emission Spectroscopy video by Claire Hans and Sean Peters. Lambda max is the wavelength at which the emission is at its maximum, meaning that the amount of energy a photon is emitted at with the greatest amount of intensity. Lambda max is controlled by the molecular composition of the dye molecule. The composition of a dye molecule, i.e. the intermolecular forces, will determine what wavelengths are emitted and what are absorbed. During the process of absorption, an electron existing in the ground state is excited to a higher energy level. An electron existing in the ground state is said to have the lowest potential energy and the highest kinetic energy. In order for an electron to absorb energy and move to a higher energy state, it must absorb the difference of energy between the energy levels. During the process of emission, a photon is emitted with the energy in order to return to a lower energy level. The energy emitted must also be exactly the same amount as the difference between energy levels. For example, a photon emitted from energy level 2 to energy level 1 would have to be equal to the difference of energies of level 1 and 2. So, in this case, a photon would have to be emitted with an energy of 10.
Based on the data gathered, the hypothesis that the observed color of the substance determines lambda max was validated. Color that is observed is determined by the wavelength of light emitted. Therefore, all other wavelength values are absorbed. Based on the data of the 1-to-1 mixture, the red line in the graph, the green dye had a lambda max at around 502 nanometers, while the red dye had a lambda max around 615 nanometers. This image shows the visible light spectra of emission wavelengths. Green light has a wavelength between 500 to 700 nanometers, and red has a wavelength around 610 to 700 nanometers. The data collected has two lambda max peaks, representing the combination of both red and green dye. In conclusion, lambda max is determined by the molecular composition of a substance. Shorter wavelengths will emit photons with a greater energy, while longer wavelengths will emit photons with a lower energy. The 1-to-1 mixture had an observed red-orange color. There were two lambda max values for the 1-to-1 mixture, representing peaks for both the green and red dye within it. The lambda max for the green and red dye are between the range of wavelengths observed in the visible light spectra. Therefore, the color of a substance does determine its lambda max.